So, Vintage Night, how it used to be done. A lot of you will already know this gear. You've seen it all and you've owned it. There's various bits of kit sitting on this desk which was actually owned by various other club members. The big brother to this one, which is sitting in my Radio Shack, was Tony's. It appeared on the table one night and I said, "What's that then, Tony?" He said, "Your next radio." And sure enough it was. And it's taken pride of place in my shack ever since. That very one there was actually owned by Derek. And again, it made its way to me because I've got a real fondness for them. It had a fault on it. It had a fault on the VFO. And the VFO was very intermittent. Fortunately, with an external VFO, that problem was solved. Just switched it onto external and used it. Anyway, I've solved the problem of the VFO. Now I took it out and took it to bits. Still has one fault that I can't find. And unfortunately, Derek's not here because I was going to ask him. And that is, why is it every time when I wind the VFO down towards the CW end of the band, the frequency disappears altogether and a little message scrolls across going, "Dear God, not again." Now, I don't know why that is. Well, I do. It got pretty well used by Derek on CW. But it's a lovely old radio, and it's still giving very good service. Anyway, let's just move on. Thank you, Mike. Unfortunately, I don't have a clicker, so I'm going to have to get Mike to I'll just keep clicking. Just go down through all of these, Mike. This is basically the timeline of what amateur radio is all about. Different things that came up, starting from the crystal set and going right down through spark gap transmitters, early valves, later valves. Then ham-specific radio equipment when it started coming out, hybrids, solid state. Whoa, you went too far. Oh, no, you didn't, that's all right. And finally, to software-defined radio, where we are now. So there's been a lot of development, and all of that has happened probably within about the last 120 years. So, moving on, please, Mike.
Sorry, just give me a moment.
Okay.
It's hard when you're trying to do two different things.
Right, okay, and again. Obviously, we all know about that. The only reason I've put that up is because it has relevance when we start talking about the hybrid radios. And I like the look of that one. Somebody, going back to our crystal set night that we had some interesting versions of them. But that one was a DX crystal set, which has got phenomenal range. And the guy that's built that has had amazing results with it. Okay, next, please. And again.
It's sat there just making noise. It will continue to do it. Just detune it.
Right. We'll have a chat about that one in a minute. Again, please, Mike. If the pictures don't come up, just move straight on. Heinrich Hertz, 1887, for those who don't know, the first sort of early spark gap transmitters and the discovery of radio waves. And again, Marconi turned them into something a little bit more practical, adding tune circuits and all sorts of things. And obviously, as you know, they turned up in the Marconi room on the Titanic. We're sending the signals out to the Carpathia saying they were in deep trouble. And all credit to the radio operator. He stayed there basically till he lost power and sank. So shortly after that, the valve arrived. Thanks, Mike. From 1916 to 1975, valve development was quite significant, starting off with the globe valves and going through the modern types, up to the sort of the miniature valves and things like that. And what that allowed us to do was to produce oscillators. And once you were able to produce oscillators, you could produce CW, and hence that's where CW came from. As I say again, this is for a lot of people who may not know this. A lot of you already do. And just for info, the spark gap transmitter was banned in 1934 because it's as wide as a barn door, and you use one of those, everybody knows. And I mean everybody. It will wipe out most things. I don't know the provenance of this, but I just thought it was an amazing bit of homebrew kit. It's obviously pre-war, looking at the valve. And I don't know if it's just a receiver or a transmitter. I can't really tell. But it was a pretty impressive bit of kit. Anybody got any thoughts on whether that might be a transmitter or not? You think it's TRF? Yeah? All right. Well, thanks for that, Andrew, because I wouldn't have known. Right. This is where it starts getting interesting, because after the war, thank you, Mike, hold there. We had a lot of MOD surplus, and that was an absolute boom time for the radio amateur, because they were able to say, well, I want one of those, I want one of those. So the R1155 and its transmitter partner, AR88s, all those sorts of things, all came into the ham arena, which was brilliant. And also we're really lucky because Brandon's got one of them over here. So you can have a look at that later if you want to. Funny story with that. I managed to source that for Brandon because he said he always wanted one, and I found out where there was one going. So I went up and collected it, and Brandon said to me, I'm not switching it on. I said, okay, bring it to my shack then. We'll put it on the Variac, we'll bring it up slowly, and we'll see what happens, which is exactly what we did. So we brought the thing up. Gradually, it started to crackle into life, and nothing was going bang, no magic smoke. And we could see the tuning eye was not doing what it should have been doing, so we sourced another one of those. Anyway, upshot was, it came up, we had a lovely hiss in the background, so we connected an antenna to it. Tuned around the bands. Sure enough, we had this crystal clear signal, speaking fluent German. And what made us laugh was, considering the last time that was used was probably over Dresden in a Halifax, so or a Lancaster. So anyway, there you are. That's the story behind Brandon's 1155. It's a lovely bit of kit, and I know Brandon's very fond of it. So that sort of equipment allowed us to do a lot of things in the amateur field that previously we weren't able to do. Thanks, Mike. Now, this again was meant for people who don't know what they are. So please, I am not teaching those to suck eggs. I'm giving you some very basic knowledge of what a valve does. Okay, just go down through until I tell you to stop, Mike. Well, thank you. Right, as you can see, a valve is what it says it is. It's got electrodes in a vacuum inside a glass envelope. And the clue, very often, to what electrodes are in it is in the name. If you consider a triode like that one there, it can be considered like a field effect transistor. It does virtually the same thing with current flow being regulated by a gate, or a grid in this case. The simplest one is the triode. There is the diode valve, which is used in rectifiers, but this is the one that basically controls and provides some gain. There's a circuit over there which is about the using a valve for an amplifier. It's actually, the circuit's wrong because it's missing several parts. It's missing a cathode resistor, which actually sets the DC bias on the cathode, and it is also missing a cathode bypass capacitor, which will allow it to keep its DC bias at the right place, but allow the AC signal to go through. So if you were really trying to use that as an amplifier, it wouldn't work. But in its very simplest form, what that valve is doing is the cathode is being heated up, it's emitting electrons which are dashing across the valve and up to the anode. Now, we all know that electrons go from negative to positive, whereas current flow is from positive to negative. And by varying the input voltage on the grid, we're able to control that flow of electrons and thus the current flow through the valve. Now, the way that works as an amplifier, if you see you've got the resistor there in the anode, the plate resistor, what's happening is, as the current is varying through that valve, there is a volt drop being developed across that resistor, and that is what is giving you your output voltage. So you're actually getting it actually in inverse phase. Okay, thanks, Mike. Apart from the diodes, as I say, things like the diode valves are usually things like the EZ80 and EZ81s. They're very, very common still in valve equipment. The ECC83, which is kind of what a triode is, although it's got two triodes in the one envelope, is probably one of the most popular valves you'll ever find. You'll find them in guitar amplifiers, you'll find them in hi-fi amplifiers. All the old 1960s record players, reel-to-reel tape recorders and things, they all had ECC83s in them. Probably coupled up with an EL84 as a power amp stage. Thanks, Mike. I won't read it all to you, but you can see exactly what I said a minute ago about the different valve types with the names giving away the number of elements. For those people who wonder why we might have extra grids, they have specific functions, and you can feed signals into them and make the valve do different things. But one of the most interesting ones that I find is the pentode and the use of the suppressor grid. Because, as I was saying about electrodes flying off the cathode and going up to the anode, a certain amount of them will bounce off the anode and start coming back down again. So you put power onto the suppressor grid and set its bias, so it goes, oh, no, you're not going that way, you're going back up again. So they bounce back off the suppressor grid and up they go. All right, everybody with me so far? Fantastic. Please don't think I'm teaching to suck eggs. Many of you will know this. One of the sorry, Mike, you've gone too far. There you are. Well, one of the most useful things about some of these valves is the fact that you can have two different valves doing different things in a common envelope. Some of you might remember I brought in a valve amplifier a little while ago, not the big one I brought in for construction night, but I brought in one which only had two valves in it. And those two valves were ECL82s. And the lovely thing about them is they contain a triode and a pentode in the same envelope. The triode is a great preamplifier. You take the output from the triode and stick it straight into the pentode to give you your power amp stage, and you'll get a couple of watts out of it. So you can build a complete audio amplifier with one valve and the appropriate power supplies. All right? Quite a useful device when you think about it. To make that work, you would probably need that one valve, forget the power supply for a minute, but you would need that one valve and probably no more than half a dozen discrete components. Right, thanks, Pete. So that's basically what the valve is, valve types. Thank you, Mike. Right, okay, now, we all know that when we put a valve into a radio or into a bit of kit, we don't know if it's any good. So, scroll down. If we've got things like cracked or broken envelopes, we know it's knackered. White deposits, we know it's gone. Excessive blackening, hold it there, Mike. So, all of those will give us a pretty good idea that the valves have got a problem. And I remember when Lynn brought his FT101ZD up and I took a look at it, I pulled the valve out of it, it's gone white. I said, you can throw that away. Oh, can we put it on the valve tester? I said, yes, but I can tell you already there will be no emissions out of that valve. So we plugged it in, and sure enough, flat down, absolutely nothing. So you can recognize the signs. Now, can we do the next ones in order, please, Mike? So I'm going to ask some questions now, and these are aimed mainly at the people who have not had much experience of kit. Looking around here, I think most of you have. Mike hasn't, Brandon hasn't, Ken hasn't, so I'm going to put, and Mark. So I'm going to ask the questions of you guys. We're going to test the valve now. First one, please. Hold there. Thanks. Heater continuity. Now, bear in mind what I said at the very beginning about the valve. Why do we check heater continuity as the first test we would do if we want to check if the valve is okay?
The valve needs a heater to work. And, well, you need it up to heat, or else it just won't do what it's supposed to do.
Any advance on that? Brandon?
Unless there are occasionally some direct emitters, but mostly it's a cathode, this is the sheath around it.
Yep.
And that has to be up to a hot temperature before it starts emitting.
Absolutely bang on. So you were right, Mike, you're right, and so are you, Brandon. It's all about the fact that without heat into the cathode, if you do have something which they would call a direct heated valve, it's a different thing. And the heater itself, if I remember rightly, Andrew, I think it's the heater itself that's actually emitting, isn't it?
Yeah, and the direct heater, no warm-up time, turn them on and go.
Yeah, it's all right. I've not had much experience with those. So there you go. If the heater's gone, your valve is completely useless. You cannot do anything with it. Okay, next, please, Mike. Heater cathode leakage. Now, bear in mind how closely related the heater is to the cathode. It's basically sat right underneath it or wrapped right round it. If you've got a short circuit between those, that valve isn't going to work properly. You can end up with all sorts of problems with your HV going back into your heater circuit. You get distortion, you get blown fuses. In fact, if you remember back a long time ago to Andrew's fault finding course that was done here, he actually put up a circuit and said it keeps on blowing fuses. Why? And the fault was a heater to cathode short. So that's the second one you look for. If you've got that, can't do anything with it. Next, please, Mike. Inter-electrode shorts. So what I was saying about the various electrodes within the valve, cathode, anode, control grid, screen grid, suppressor grid, just taking a pentode as an example. You don't want any of them to be short-circuited to each other, but there is a caveat to that, which I'll come on to. The reason for that is because you might want them doing totally different things. They might be biased at different voltages. They might be taking different signals into that valve. So on that basis, you need them to be completely electrically independent. The caveat being that sometimes, particularly if you're an audio engineer, you might decide that you want to use a pentode valve, but your client says, but I like the sound of a triode, because they do sound different. And if they do that, you can achieve it, because you can do what's called triode strapping. And what you do then is you connect two of the electrodes together. Normally, if I remember rightly, it's the suppressor grid gets strapped to the cathode. And that gives you effectively the performance of a triode and the sound of a triode, but with those electrodes shorted together. All right? So that's an intentional decision that you make. It's not that something's gone wrong in the valve. Okay, next please, Mike. Static test. If you've got some good equipment, unfortunately I don't, but if you've got some really good equipment, you can actually do what's called a static test, where you plug the valve into the tester, you open the manufacturer's data book, and you say, anode voltage is this, grid voltage is this, screen voltage is this, heater voltage is this, and then you can do a whole series of tests on that valve to make sure that it is emitting properly, that it is performing properly, that its mutual conductance is correct. I'll come on to that in a minute. But that's the static test, and I'll show you how it's done in a minute. Okay, thanks, Mike. If somebody says your valve's gone gassy, it doesn't mean it's emitting nasty smells and throwing you out the shack. But what it does mean is that air or oxygen or some other gas has got inside the valve envelope, and it is either preventing it working. You might not be able to detect it visually because it hasn't gone white, but there could still be a small percentage of oxygen in there, which has resulted from somebody pulling the valve out roughly and just cracking the seal around the base pin, something like that. Mutual conductance test. Remember what I said about the with the triode, where by varying the voltage on the grid, you control the current through the valve. That is basically what the mutual conductance is. There is a relationship between the current that the valve will take depending on what voltage you stick into the grid. I'm not going to try and go into detail because, to be honest, I need a book in front of me to do that. But in its simplest terms, that is what it's doing. Andrew, correct me if I'm wrong.
That's correct, yeah.
Okay, thank you. So that's your mutual conductance. Okay, Mike?
Can I just ask, would it say GM test as mutual conductance? What's a GM?
Very good question. GM is basically what they have used it as the designation. I have no idea where the G comes from. Can anybody answer that one? No? Okay, thank you. Okay, so we can go, if we want to check a valve is okay, we can do it with a simple emissions tester, or we can go with a full-on circuit conditions tester. Now there we go. I've got one of these, that little conar, and it's a brilliant bit of kit just to plug a valve in and see whether or not you've got a working valve. What it can do is it can check heater continuity, it can check for heater to cathode shorts, it can check for inter-electrode shorts, and it can do a basic emissions test. And it does it by effectively strapping all of the electrodes together and just doing a test that it's chucking some electrons around. It doesn't actually tell me what the mutual conductance is. I can't measure the mutual conductance. All I know is that by sticking in the currents and the voltages that the book tells me to put in, it'll tell me whether it's green or whether it's red. Useful tool, but I want one of them. I would give my right arm for one of them. That is a Mark V AVO full GM tester. That can do absolutely everything. You get a data book about this thick, and it's probably got every valve ever produced, and you can plug them into the top in various places, and you can set them up under full circuit conditions. But the nice thing about it is you can also set them up under the conditions that you are designing to. So you could plug the valve in and say, well, actually, the manufacturer's data says I want an anode voltage of 275 volts. My circuit's not going to work at that. My circuit's going to work at 250 volts. What's the effect? So you can set the tester up, crank it down, and once you've done that, it'll still tell you how that valve is performing. So a really, really useful bit of kit, but it's a big bulky thing. I mean, it's about that wide, it stands about that high, and it's about that deep. So, and you need two people to carry it. But I very nearly got one, not all that long back, the Mark IV. But the problem is the roller switch is right in the very top of the box, which actually set all of the pins of the valve to the right test circuits. They were all seized up. So I had to send it back to the seller and say, sorry, this is just not marketable. They were very good about it. They said, no, okay, we didn't know. We do now. And they just refunded me. But I was disappointed. So now we start onto the hybrid radios, which is what we were actually going to talk about tonight. There were two main types of valves used, possibly more, but the two main ones. Okay, if we bring the next one as well, Mike. Thank you. Stop. That's great. Were these. The 6JS6 was used in the FT101s. And they were very, very common valves, very useful valves. They were actually known as a sweep valve. And they were used in TV circuits for quite a long time. They are now quite rare. And if you get hold of a couple of decent match 6JS6s, they are worth holding on to. Excuse me a moment. It's drying up slightly. Yeah, if you try to buy them, they are pretty expensive. So what people have now started doing is they've started modifying things like the old FT101s from the original FT101 right through to the FT101E. They're modifying them to use the 6146. Now, all the Kenwoods are running on the 6146s. So this is running on 6146. Chris, I don't know what your Heathkit's running on. That's 6146 as well? Okay. A fairly common valve, power pentode. So 5 electrodes, guys, for those who are thinking pentodes. Very good valve, very robust valve, not overly expensive. Bern?
6146, I had a triple pair, 6146B.
Yeah.
What would the B be?
Just a model designation, I should imagine, because, for example, the 6JS6, they came out with a B version, a C version. Sometimes a code...
drive current was 65 milliamps as opposed to 50 on the A's.
Oh, thanks, Chris. I didn't know that. Yeah. The other thing is sometimes they put a designatory letter on the end of a valve or somewhere in the code to designate it that it is, for example, it's been a ruggedized military spec valve or something like that.
That was a W's.
Yep.
On the 6146, the military version is a W.
Thank you, Chris. Again, I didn't know that. So this is why I say, there are guys in this room who know more about this than I do. The only reason I'm doing this presentation, guys, is I've been badgering people to do one for long enough. I thought it was about time I'd better do one myself. Otherwise, people are going to say, well, why don't you do it? So anyway, this is bringing us on then. Now, we're now in the 1960s. And we're starting to get into purpose-built ham radio kit using valves. So we've got some very nice KW there. Got the Kodar. The Kodar was mainly CW based. And for anybody who came along to the show and tell night, you will know that Peter, VFG, very kindly brought in a Kodar. We had it set up in the back corner over there, and he was sending on it. So we know about that. The Heath kit, Chris has brought his Heath kit in, which is absolutely brilliant. And also over here, in case you didn't spot it, is a Heath kit RA1, which is a ham bands only full valve receiver. The nice thing about Heath kit is it totally fostered the whole ethos of ham radio in that it was encouraging you to build your own kit. Probably the only people doing that now are the likes of Elecraft. And when you look at the size of some of the components in the Elecraft, it's kind of, yeah, right. Personally, if I can't pick it up, look at it, and identify it around about here, it's too small, which is why I like bottles. I can pick them up, look at them, read the numbers, and plug them in. So anyway, that was Kodar and Heathkit. Then we got into Yaesu. Now, I do apologise for any ICOM users. I do not know the ICOM range. I don't know whether or not they did anything in the sort of the 60s and 70s of the hybrid type. I've never come across one, and I do try and keep up to date with what happened back then. So if anybody knows of any ICOM stuff, I do apologise. I'm not covering it because I literally am not familiar with any.
ICOM might not have existed. It might have been known as something else.
Possibly.
We're just doing their 60th anniversary this year.
ICOM-R.
Yeah. So, basically...
So that would put them back to about the that would put them back to the 1960s, wouldn't it? 1960s, 1970s. for ICOM. So as I say, they were probably not doing this kind of kit. But Yaesu were. And down there we've got the FR100 and the FT100, which was the matching pair, fully analog transceiver and receiver. Now this will tell you how anal I am. The speaker in the middle isn't matching. It's not the right one. That belongs with a Trio 9R59. It's a receiver speaker. It does not match the Yaesu kit at all. So that really shouldn't be there. But, it kind of fits. But it's not the right one. Thanks, Mike. So, valve ham radio in the 70s. Okay. Hold it there. That's great. So this was now the advent of where the first sort of higher specification hybrid radios came out. They were moving away from full valve installations, and they were moving into using a lot more transistors and things. But back then, power transistors were still hellishly expensive, and used in a lot of high-end kit. But for the amateur, it was still a lot of money to buy power transistors and things that would carry the kind of outputs that we wanted. So, as a result of that, we ended up going down the route of hybrid transceivers, where we had the, well, let's move on a bit, Mike, because I think I've covered it a bit further on. That was the FT101. Sorry, I'll cover a bit more in a second. That was the FT101 that ran from 1970 to 79. And we've got one over there. That's an FT101B. Again, fortunately, I've had some help recently in kind of resurrecting that one. It's now working. Still needs a few tweaks, but it is actually working. But as I said earlier on, that was the 6JS6. And that was 7.3 magazine from October 1972. I don't think we get away with that now, do you? American Magazine, so 1972. Okay. Can we get a few operators like that around, please, guys? Next slide, please, Mike. So, this now tells you a little bit more about the hybrids. When Yaesu were doing the FT101s, and then moving on to the 101 and the Z and then the ZD, Kenwood was moving on with the TS 500 range, 800 range, and also the little 120 range. You can open the rest of the slide. One more. Thanks, Mike. Stop there. So there we're looking at the kit that was available to us at the time. Now, the 120 is a little bit of an anomaly in there because it wasn't a hybrid. That one was a fully transistorized solid-state radio, but I put it in because it was around about the same time as the 520 and the 830 and the 101 ZD, and it was designed as a sort of a compact radio, as I say, of that era. Whoa. The thing with the on-air performance of the hybrid radio, because of the valves, you get a lot of real warmth and depth in the audio. Those of you who have used them and know them, Tony, you know this because of your 830. John, you've used them. I think most people in this room, or a lot of people in this room, have used them. And you know that people will say to you, that's lovely audio quality. And it's all down to the very, very analog characteristics of the valves. Okay, thanks, Mike. So, yeah.
One thing I think you missed out on there, no, it's no criticism, is the dear old Trio 2200G.
Possibly, Chris.
2 meters, all transistorized, the very first 2-meter, if you like, multi-channeled 2-meter radio.
Would that be something like the Yaesu FT290R that I've got over here?
No, it's even more crude than that, in a way.
Right.
It was 1 watt out and had 12 crystal channels in it.
Right.
But really, it was the first of the 2-meter radios, as for mobile use and portable use, that, if you like, you're so used to with your Bofangs and your goodness knows what nowadays, etc.
Yeah.
That's what started it all off.
Okay. Thanks for that, Chris. I wasn't...
I should have brought mine in. I do have an original Trio 2200G.
Be nice to see that sometime. It's not a radio I'm familiar with, and one of the things about tonight was, was mainly to focus on, for example, the valves and the valve hybrids. I mentioned a couple of the transistorized ones, obviously, for what I thought was completeness. But yeah, I've not touched on 2 meter. Ken?
Yeah, just a quick, you say hybrid, obviously it's transistorized and valve.
Yep.
The valves only used for the output?
I'll come into that. Right, so what is a hybrid radio? Well, this is exactly what Ken's just about to ask. We've got, hold it there, Mike. We've got a combination now of solid state and some digital electronics, for example, the phase lock loop and whatever that appears in the frequency counters and things like that in those. And all the solid state stuff is doing it's doing its amplification, it's processing the audio, and it's doing the tuning. What it doesn't do is it doesn't do the power amplification, and that is what the valves are doing. So we're feeding a very, very nice solid state signal out through a driver valve into effectively the power amplifier stage, which is made up of the 2 valves. Okay? Thanks. Again, what I was saying, high power transistors were expensive, valves were cheap by comparison. And I mean, to be honest, we've all done it, haven't we? We've all thought, actually, I can change that valve out and plug a new one in. Sometimes you will, sometimes you won't want to do that with a transistorized bit of kit or something with, really tiny kit, chips and things. So TV valves were really popular back then as well. So they were a cheap way of producing quite a high power output. So that's one of the reasons why the hybrid became very popular. Okay, one more, Mike. Thanks. Hold it. Again, as I said, the on-air audio's got that lovely sound that only valves will give you. The BBC, as you know, are still using valves in some of their high power transmitters. The problem is going to be when those valves are expired and end their useful life, there are no more. There are no more being made. So those transmitters eventually will go off the air. Now, there's people in this room that will know more about that than me. But it will be a sad day when that happens, because gradually all of the old medium wave transmitters and things that were running on valves will gradually disappear. Yeah. Mark?
I saw a picture ages and ages ago. A bloke from the BBC had got like a trolley.
Yep.
And the valve, I'm not joking, the valve that he was carrying was like this high, and it was about a foot across.
Yep.
And it was absolutely massive.
Yep. Yeah, that's common for a transmitter valve. If you, there is a very, very interesting guy on YouTube, if you ever get a chance to watch him, called Mr. Carlson's Lab. If you have a look at Mr. Carlson's Lab and have a look at the videos on his AM transmitter, he actually stands inside the transmitter with the valve beside him, and the valve is nearly as big as he is. It's phenomenal. Okay, next please, Mike. I'm not going to ask you to look in this in detail, but I put it up for one very simple reason. That's the block diagram of the TS830S, which is the bigger brother of this one that's sitting at home in my shack. All we've got is all these little arrows or different stages through the block diagram are all solid state until we get to here. And that's where our power amplifier is, our valves. And right there are 3 tank circuits. And I'll explain what those are for in a minute. Because they are very, very important when it comes down to a hybrid radio. So we've got all of our stuff solid state coming through, power amplification there and up the antenna. When we come back down the antenna, we're solid state all the way back to the speaker, and we're solid state and digital through the signal processing. Okay? Thanks, Mike. That's what's inside the PA cage of a hybrid receiver. So that's a pair of 6146s. That's actually the inside picture of one of these, a 530S. What I will say to you is, if you do ever decide to get involved in one of these, don't put your fingers in there. Because sitting underneath those very nice little red caps is around about 700 volts, if not higher. Not only that, you've got all sorts of stuff going on in there that you don't want to get any part of your anatomy in contact with. If that was a linear amplifier and you were using the big power bottles for it, the voltage on those caps could be up to around about 2,500 volts. So you really don't want to be in there unless you want to be. Just as a comparison, if you're looking at those sorts of voltages in there, in the audio amplifier that I brought in for the construction night, the anode voltage on that was around about 275 volts. And that was still giving quite a lot of output, but it's nowhere near what's up there. But also in there, you can see the tuning capacitors and you can see the coils of the tank circuits, which are the resonance circuits that have got to be sort of on song and in sync with each other to actually make this thing produce the output it should produce. Okay, thanks, Mike.
Just a quick question. This is a matter
Yep.
of interest with Jeff. That box,
Yep.
you can look inside an HW101 and it almost is a mirror image.
Yeah,
It's just an image, exactly the same.
it is. They are all very, very similar.
Although an FT101D had 3 valves in it.
News to me. I didn't know that. That's right. Sorry, Ken, I'll come.
No, all 6146.
Yeah. Mark? Sorry.
You were talking about how high the voltage, you know, from those things. If you switch the thing off, do they retain the voltage for a long time?
If you don't discharge the high voltage capacitors, yes, you will still have voltage in there.
30 seconds.
Yeah. You don't put your finger straight into it. I'll come to you.
Screwdriver in there.
Yeah. Jesus. You have what we call the Jesus screwdriver, which you put it across the cap and it goes, Jesus. So that's the way of solving that. Hang on, Mike. Ken?
You mentioned earlier about valves having a white powdery interior.
Yeah.
They are white.
That's an optical illusion, that is, Ken. What you're looking down is you're looking down on the very top of the silvered form of the. Yeah. I've actually got a couple of 6JS6s that I brought with me. I can actually show you one if you wanted to see one. But I've not got any 6148s because I've got one good pair of those, and I'm not going to bring them out until I absolutely need them. So anyway, that's what's inside the PA cage. Mike.
Just a quick question. With all the high voltages and everything and how it all works, what's it like about working in damp environments? Because now obviously we now got central heating and everything else like that. Back then, I know there was a lot of damp in houses, and especially in your workshop sheds. Yeah, sheds. Yeah, still have. But what was it? Did you have to make sure you were in a dry environment, or wasn't it not too bad?
Frankly, I wouldn't want to use a hybrid transceiver in a damp environment. But don't forget, the minute you switch that thing on, you've got 2 stonking great heaters at the bottom of it. So you are blowing a lot of hot air through that. I mean, when I've been, for example, on the Saturday morning net talking to Derek or Tony, if I stick my hand down the back of my rig, it's kind of, sheesh. There's a lot of heat blowing out of that. So, any questions more on the PA cage? Okay, thanks. Next, please, Mike.
Jeff,
Sorry, John.
you're on about damp environments.
Yeah.
Going back to Jeff ELZ's time, we were in Bath Lane in Torquay,
Yeah.
and back then we had not only an FT200 Yaesu, which is the early one, we also had FT400, and they had a separate power supply.
Mm-hmm.
Quite often, the diodes and what would blow, and that turned out to be the damp, and we ended up with, we got bags of silica gel and stuff that inside.
Oh, so inside the power supply.
Yeah.
Was that the FTDX 400? That was an early Yaesu.
Yeah, it's the big Yaesu, that was a monster.
Yeah, I've seen
Nine
pictures.
output bottles as well, and you had to tune it very quickly or it went pop.
Yeah. Okay. Thanks, Mike. You had a question?
Yeah, DC, you simply get a shock. But if you stick your finger on one of those, it's RF. And as you take your finger off, the bleeding voltage follows you.
It will. Yeah. You don't want to do it. Okay. So the whole big question is, all you people with, nice SDR radios and things like that, is okay. So you talk to me about hybrid radio, but what's different to a modern radio? Well, that's the first thing. It takes a little bit of time to warm up and stabilize, and it drifts for a while. They will drift initially, if they are left to get really, really cold and damp, they will drift like an unmoored boat until they warm through. Now, the other thing is, now moving on to what we were talking about in the PA cage, the PA tank circuit has got to be tuned specifically to the band and the frequency that you are going to use, or you will damage the valves and you won't get the required output. Okay? They are a bit more tolerant of SWR issues on antennas, but personally I wouldn't trust it. I believe if you're going to tune it up, you tune it up properly, you tune the antenna properly, and then you go ahead and transmit. So, hold there. It does mean it takes you longer to get on the air. You're not going to push the button on, tune, CQ. That's not going to happen. So if you want that kind of quickness, don't buy or get yourself a hybrid radio, because in this world, everything goes much more slowly. You just lay back like the caramel bunny. Okay, next please, Mike. Hold there. Right. You need to know the tuning procedure. If you don't know the tuning procedure, damn well learn it before you start playing with the thing, because if you don't, you're going to do some damage. Okay, next. And like a lot of members of this club, they're now elderly and fragile and need to be treated with care and respect. So this is one of the reasons we were talking earlier on about the ruggedized valves and things like that. Personally speaking, I would not recommend anybody taking one of these out as a field station radio. They'll do it, but you don't know what damage you're going to do if it's been bouncing around in the back of a car. You know, talking about the valves themselves, it's very easy for that anode in the heater, or the cathode in the heater rather, to vibrate into each other. You end up with a short, you key up, bang, and you've taken out a section of your radio. So field radio, it's not really practical. Okay, Mike, thanks. There you are, the very high voltages, anything between 600 and a kilovolt, depending on the radio. So this is another question people keep asking. Can a hybrid do everything a modern transceiver can do? Well, yes, but there are some significant caveats. Okay, hold there a minute. Voice CW, absolutely no problem. It can do it all, and it can do it all very, very well. Okay. Digital, hold there. Digital can be used, but bear in mind frequency drift, everything else like that, very difficult. What I have done with one for a bit of fun is I've used an app on my phone. So I've tuned the radio in onto a digital mode. In fact, I did it with my 830 at home. Tuned it up on FT8, stuck the phone beside it, and I could see exactly who was calling and what they were calling. But transmitting back is much more difficult for a couple of other reasons. Cat control of the radio frequency. Okay, Mike. You could possibly do it by using the external VFO inputs. Now, we've got an external VFO here. So you could build an interface that takes a signal from the computer, turn it into an analog voltage that would work through the VFO input. But I wouldn't recommend it, and I wouldn't necessarily think it would be particularly stable. And what it also doesn't do, and this is vital, remember what I said about tuning the tank circuit. Every time you move frequency by not very much, I personally retune my tank circuit even if I'm going up or down 5 kcs up the band. So every time your computer tries to retune your radio, you're going to have to be there retweaking the tank circuit anyway. So if you're going to do that, why not just turn the VFO yourself? Why put cat control on it? Can you work a split? All these people with dual VFO radios, can I work split with different transmit and receive frequencies? Yeah, you can. Because what you need is you need one of them. You connect one of those to the radio, and now we've effectively got a radio with 2 VFOs. And we can actually set one to the transmit frequency, and we can set one to the receive frequency. As good practice, and it's entirely up to you how you do it, but as good practice, for me, I would always tune the radio as the main, as the transmit frequency, and tune the tank circuit to that, and then have the receive frequency on the remote VFO. So if you're listening, say 5 up, you don't matter what your tank circuit's doing, but as soon as you key up, that tank circuit's got to be on resonance. So you set your tank circuit for transmit, and then you listen on the remote VFO. But again, it's entirely up to you. You can do it whichever way you like. With that remote VFO, you can actually set it to be transmit, receive. You can set it to be the main VFO where it does everything. So it gives you a lot of flexibility with that. I was very lucky. I had a VFO 120, which was the baby one that goes with the 120 series radios, which works perfectly with the 830 and the 530. But again, being one of these who wants the proper lineup, I found that one recently. So I'll have that, please. So it's just kind of building the lineup up. Thank you. Right. So what's the disadvantage of owning one? Okay. Hold it there. That's really what it's all about. It is like owning a classic car. it's going to cause you a few issues. It's not always going to start right. And you are the custodian of a piece of history. That's what I regard this as. I don't regard myself as the owner of this lineup. I'm looking after this until some younger operator comes along and takes it off my hands and actually keeps it on the air. I'd love to see this thing going on for another 50 years. Okay? This is one of the biggest problems now with these hybrid sets, is there are certain things in them which are bespoke parts. For example, if you lose the digital display controller in this, the radio's gone. Unless you can find somebody that's breaking one, because you can't get all the bits anymore. Tubes, you can generally find a workaround. Sometimes, for something like a frequency readout, you could probably find a workaround. You can build a frequency counter and find a way of tying it in somehow. But some of the more bespoke bits are becoming harder and harder to get, particularly with things like the 101s and things like that. Chris probably found the same when he was looking at doing his Heath kit. So, yeah. Mm.
As time goes on,
The internet is very useful.
that's going to diminish and diminish. So, you can only break down so many bits until you've got none left.
Yeah. So sometimes it's wise to kind of, if you know somebody is going to throw one out, grab it, stick it under the shack bench, because it might well get you out of a hole later. Okay, thanks, mate. Picking up the next one, as I said, it does take time and effort to get the best performance out of it. So you just don't switch on and go for it. It's not going to happen. The tune-up procedure we've already talked about. If you abuse it, the appearance of magic smoke or a glowing radio means you've done something wrong. So be careful. And if you're a contester, a hybrid's probably not for you anymore. Back in the day, when everybody was using them, it was kind of easier. You could keep up. But I've got to be honest, if I was on a contest and I was up against Tony with his Elecraft and Phil with his FTDX and whatever, there's no way I'd catch up with them, because I couldn't move bands quick enough, find somebody, tune up, call them, get the call back, find the next person, tune up, call them, and do it, because you're not only tuning the radio, you're also tuning the antenna as well. So it's not a quick process. And using certain modes and computer integration is difficult with a hybrid. So, yeah. Well, this is the reason why. This is the reason why I like having people in here that have done all this, because there's little nuggets like that which come in, and you learn from it. Okay, so hold it there. Just read that statement, guys, because that's one of my favourites. Yeah, ham radio operator, hybrid radio operators consist that menus are for restaurants and real radios glow. So this is one of the things with them. They have a character, and they're fun. Once you get used to their little quirks, they can be a lot of fun. Okay, next one. Thanks. Going back to what I was saying about the maintainability, assuming you can get the parts, you can fix them in the shack. It doesn't take very much to do them, because it's all large components mainly. Hold there for a second. As an example, I brought along a couple of other bits of kit over here, and something like an audio frequency generator, an RF frequency generator, and a nice old-fashioned Nixie tube scope, a Nixie tube frequency counter. Ken's very pleased to see that one, because Ken gave that one to me a long time ago and said, don't even think it works, see if you can get it to go. So fortunately it does now go, but it's had quite a lot of faffing about with, because the heater in the crystal-controlled crystal reference had packed up, and it was totally overheating, and you could watch it, and you would set it to a frequency, and then it would just keep on decrementing down and down and down as the crystal got hotter and hotter and hotter. So to overcome that, I've put in a thermal switch set at 50 degrees C in series with the heater circuit itself. And I've now got it that once it's been on for about an hour and a half, comparing it against my very, very nice Marconi, Thank you, Andrew, for making me spend such a fortune on that. Comparing it against that, I've now got that thing stable down to about 2 hertz. So I'm actually quite pleased, and I'm quite pleased that it's working as well as it is. So thank you for that, Ken. I'm glad you're happy it's working. Yeah. But anyway, that's the kind of kit that people would have been working with. That and a simple oscilloscope. So you've got AF, RF, a frequency counter, and your scope. Now, I mean, I'll come to that in a minute. We've done that one. One knob, one job. Don't you just love it? You go in, you don't have to go through all the menus and the sub-menus. It's just, that's the control I want, job done. It's an absolute joy to use in that respect. And this is the thing for, this is the thing for anybody who is sort of starting out. A good hybrid, it's a cracking radio, and they don't cost a huge amount of money. You can fix them, but the fact that you've got to know about tank circuits, tuning them up, manual tuning of the antenna, unless you just decide to get your hybrid and then buy something like an MFJ auto tune, which kind of takes the fun out of it. They're a fantastic teaching aid for anybody who's getting into the hobby and wants to learn more about how these things work. Once you start knowing about resonance, and particularly things like, using your ears, you can hear when an antenna is coming into resonance, or into matching, I should say. Anyway, okay, next one. Yeah, exactly. What's the It keeps the shack warm. One of the most important things of a hybrid radio is it keeps the shack warm. Okay. As you can see, go on, one more. That is my cat, Neru. She got in the shack one day with me, and it was a particularly cold day out. She had a bit of a cuddle on my lap, and then she decided she didn't want to be there anymore. She started sniffing around the shack. Next thing I know, she's curled up very happily on the top of my Eddystone 830. And it was warm as toast up there. And she was very, very happy. So she comes in on a regular basis and tries to sit on something. Anyway, there we go. It's the only cat control you'll get. Come on, I had to put it in, guys. Give me a break. Okay, Mike, next one. So what we're going to do now, just scroll down through all of this one a minute, right down to the bottom slide, if you would. If anybody wants to, we'll actually see if we can get this thing on the air. We'll do some practical demonstrations of how to set it up. In fact, perhaps one of our experienced operators who's used these in the past would like to actually do that in place of me, because you've probably heard enough of me already. So we've got it here to have a play with, and we can see if we can get it on the air. It's connected to the antenna. So initially, that's about setting up the radio itself. Okay? So I won't read it all because there's quite a lot of it there. But it is all about how we check the bias current, we dip the plate, we then tune the tank circuit into resonance to get maximum RF out. And then once we know that we're on maximum RF into the dummy load, we then leave the radio alone and we start working on the antenna. Next, please, Mike. So we want one of them. That's the manual ATU. That one has got significance today, guys, that manual ATU. It came to me via Lynn, again, because he knows I was sort of building up the lineup. But prior to that, it belonged to a very good friend of ours in the club, and it would have been his birthday today, and I'm talking of Roger Gill. So, Roger, if you're watching or listening, your ATU's here, and thank you for it. So, again, that's why I say about being custodians of this kind of kit. It comes to us from all sorts of sources, and everything has a little bit of meaning. So the manual ATU, if you've not used one before, by all means have a go, tune up the antenna with it. Next point, please. And, okay, away you go. The biggest trick I find with a manual ATU is use your ears. If you use your ears and you've got that ATU set to the right band and you start tweaking the transmitter and the antenna side on the various controls, you'll hear when that matching is coming in, because you can watch it on the S meter. You'll see the signal increasing and you'll hear the noise building up. So tune for maximum noise. If you tune for maximum noise, you're probably not going to be far off resonant. Then you can start putting the transceiver into tune mode, and you can start sending power into the antenna and have a look and see what your reflected power is, your forward power, and ultimately your SWR as well. And then once you're tuned up on that, then you can call CQ. John? Yeah. So on a new manual one, yeah. Yeah. See, the thing is, John, some people haven't actually used a manual ATU. They've just gone in, they've used the one in the rig, or they've bought a separate push-button ATU that does everything for them. The whole purpose of this was to try and get people to use the old stuff and how it was previously done. Sorry, John, I'd struggle. Yeah. Well, maybe you could demo that one then. All right. Okay, so we're getting to the very end of it now, guys. We've talked about how to work a split. Okay, Mike? Must be tuned, the tank circuit must be tuned for the TX frequency, and you've got the remote VFO for doing it. Okay? Now, whoa. How to monitor your signal quality. A lot of people with hybrid rigs, the first thing they'll do is they'll screw the gain up and up and up, and then somebody will come back and say, oh, blimey, there's distortion in your audio. Not very nice sound. Or if you get it set up right, somebody will come back and say, oh, what beautiful audio you've got. The trick, next one, is one of them. And that's one of these here. That, again, was a recent acquisition. I did a bid snipe on eBay on that one and won it in the last 5 seconds of the bid. I couldn't resist. But that is a station monitor. And with that powered up and with the signal passing through it, you can actually monitor exactly what your envelope would look like. One more? Thanks. And what you're looking for, that's just with a tone sent through. That's not with a voice. But you're looking for those nice, smooth, rounded envelope, which will, with no distortion, no flat topping. If those peaks came up and had a flat top across them, you're overdriving, and basically you're clipping your audio. So the station monitor... Sorry? Or Italian, yeah. If you're Italian, you'll probably have a scope that stands about that tall because you need that to cover the bandwidth. So that's what you're looking for. You're looking for a nice smooth signal. The other thing this can do, and sadly it doesn't have the attachment in it for it, if you get hold of what's called a BS5 to work with a 530 or a BS8, the BS8 attachment, which plugs into the board on that, allows it to work as a band scope. And you can set it to either do 20 kilohertz either side of your nominated frequency or 100 kilohertz either side of your nominated frequency. So you can see, who's on the air and where they are. Sadly, that one doesn't have it. So the only thing I can do with that really is just to monitor what the radio is putting out in terms of its signal quality. But again, it's a nice little bit of kit to have to complete the lineup. So that kind of brings us to the point now where if people want to try and get this thing on the air, more than happy to do it. Now, I was going to see if we could do some CW on it if Derek was here, but obviously he's not. And also, I found out today, for some reason, with the key plugged in the back of the radio, I think I might have not checked the connections on this radio, or I've not got a setting right, because I'm getting a side tone, but I'm not getting any RF out of it. So I suspect I've got a connection issue on the key. Any further questions, guys? If there's no further questions, gentlemen, all it's left for me to do is to say thanks very much for coming along tonight. Thank you for your interest. I hope something's been of interest for you. I know probably a lot of you already knew a lot of what I was going to say, but there's a decent selection of kit here for you to have a look at, and I hope you've enjoyed the presentation. Thank you very much. Let's see if we can tune it up on 3663 for the club net and see if anybody's out there. So, the speaker, by the way, belongs to the club. It was the one piece of kit that I don't have yet. So, 3663. Yeah, that's what I'm going to now. Yeah. So, right, the first thing I've done is I've put the antenna tuner onto 80 meters, and I've got it on antenna 1. And the first thing I'm going to do is I'm going to check my frequency here to make sure that I've got 3663, which is what we want. I'm currently in tune mode, so I'm going to turn the volume control up, and I'm going to peak the drive. So as you can hear, the drive's gone down. That's kind of around about a peak. What I'm going to try and do is get a bit more signal by adjusting the ATU. Right, and I'm not currently getting any additional signal. But what I'm going to do now is I'm going to tune the radio on that 3663. So I put it onto dummy load, and I set the switch to IP, which is the plate current. So what I'm going to do now is, with it on the dummy load, I'm going to flick send. First thing I'm going to do is I'm going to make sure that the plate is set where it should be. So into send, and I'm dipping the plate. That's found the dip. Now what I'm going to do is I'm going to try and pick up the load with it in RF position. See if we can get a decent amount of RF out. Now I've got about maximum there. Now I'm going to go back again, and I'm going to re-dip the plate. I still don't think, there we are, we've got a bit more drive now. So I'm now re-dipping the plate. I'm looking for a dip on the needle, which is right there. Give the valves a chance to recover. Let me go back to the load control, set to RF, and we try and peak up the RF a little bit more. Now, as you can see, we're getting up now to around about 50 watts. Forward power going out on the RF, okay? So what I'm going to do now is I'm going to go up to CW mode, and I'm going to now dip the plate again. Just to see if we can get any further adjustment out of it. Hang on a minute, it might be, I'm going to take that key out the back. I'm not getting any, there we are, that's better. So I'm now going to dip the plate again. There we go, that's now found the dip point. Change to RF and peak the load. So we're now getting just over 100 watts, you see, up there, and it's being picked up on Chris's set as well. So now that radio is now set up and tuned for the for that frequency. Now I'm not going to worry about what's going on here, I'm not going to touch that. So now what we need to do is we now need to tune the antenna. So we've already got the antenna set. It's picking up sound as well, by the way. Oh, right, sorry, yeah. Right, so we've now got antenna 1 selected, which is the antenna we're on. So what I'm going to do is I'm going to see now, when I send, what I'm getting in reflected power. Now, chances are that's going to go quite high. Hang on, I need to be on tune to do it. Actual fact, it looks like it's pretty good. It's not that far off where it should be. What I'm going to do is I'm just going to go on to calibrate and see if I can see what the SWR is doing. Now, the SWR is not too bad. Oh, hang on a minute. It would help if I actually put it onto antenna tune. There we are. Now we're tuning. Before I was... Yeah, we should be getting better than that on this antenna. There she is, she's down a bit. See what I mean about being very, very sensitive? Right, that's about as good as we're going to get. which is not that far off where we need to be. I mean, that's giving us about 1.5 to 1, which I don't think is bad. Frequency will alter very slightly because we're over in tune. Now, if I now switch this to CW, and I do that procedure again over here, we will be able to tweak that SWR down a bit more, because we're now chucking a bit more RF through it. There it goes, it's dropped again. And again. Give the valves a rest. Always give the valves a rest. You shouldn't tune up for more than about 10 seconds. So now we give it another tweak. You can see how sensitive that is. That's probably about as good as we're going to get. All right, which is probably not that bad. So now the radio and the ATU is all tuned up to exactly where it should be. So now we go on to LSB. We're still bang on frequency. We are now ready to transmit. So now what we're doing, if we look over here, and I turn up the intensity on the band scope a little bit, so you can see what's going on. When I transmit into the microphone, and what I'm going to do is I'm going to see if I do a CQ Tour bayonet, see if anybody's out there. So now we're going to be looking at the envelope that is going out from the radio. So CQ Tour bayonet, CQ Tour bayonet, CQ Tour bayonet. Let's try that again. See if we're actually getting anything. Should be in monitor, that would be the best one. CQ Tour bayonet, CQ Tour bayonet, CQ Tour bayonet. This is G3NJA. G3NJA calling CQ Tour bayonet and listening for any contacts. Nobody listening at the moment. Well, no, it isn't, but we'll always try again in a minute. CQ Tour bayonet, CQ Tour bayonet, CQ Tour bayonet. This is G3NJA stroke A. G3NJA stroke A. Calling CQ Tour bayonet, CQ Tour bayonet, and listening. And that, my friends, is how you tune up a hybrid radio and put it on the air using a manual antenna tuner and tuning the tank circuit for the club net. Hope it's been interesting. If anybody would like to take over and put some calls out on for the net, they're more than welcome.